Hi there, and welcome to our lecture on graphing. Our key idea for this lecture is why is organizing data an important science skill? So to begin answering that question, we can say because scientists use written reports and oral presentations to share their results, organizing and presenting data are important science skills. So a lot of times we add graphs into these written reports so we can better communicate what is going on or what our data is indicating. So to start, our first graph that we're going to look at is a line graph, and these are best for continuous change. So two vocab words here, independent variable, dependent variable, are things you probably have seen before. The independent variable are values that are set before the experiment. We also plot this on the y-axis, or that bottom line on a graph. The other is the dependent variable, which depends upon what we do to the independent variable. So it'll change depending on what happens in the experiment. And we plot that on the y-axis. So looking at our graph here, we've got our independent variable along the x-axis. So we're going to call this the x-axis, or independent variable. And then on the side of the graph, we've got our y-axis. See if I can draw a straight line. Which is also the dependent variable. So what we've got here is we've got a graph that's measuring time, and we're changing time and how the volume of the gas changes over time. And we've got that title that's indicated here, so volume measured over a given amount of time. So when we're given a graph, we have to set our units. So our information that we put on the x or y axis, we have to set it equal increments, and we have to have an equal spread of information on the x and y axis. So notice on this graph we've got from 0 up to 180 on both the x and the y axis, and they are divided by 20 second increments on the bottom, and then 20 milliliter increments going up to the side. But notice how we use the entire graph to show what's going on with this data. So we had this data and we plotted, we started 0, 0, so that's plotted down here. And then we go time 20 seconds, volume 6, so that was represented here, and then so on. So this is our x, and you can think of this as our x and y here as well. So this is, when I'm using the x, this is how much I go from left to right. And then when I use the y information, this is how much I go from bottom to top. And then I go ahead and connect the dots to show what kind of trend I have. So I have this upward trend on this particular graph for whatever this experiment was. And also, when we're plugging in a graph or filling out a graph, we're going to have a title here that describes what the graph is trying to show. So here, volume measured over time. So how much of this gas, we don't know what the gas is, but just for an example, the volume of the gas and how this volume changes over a given time. The next kind of graph we have is a bar graph, and these are a graph that we can use to compare different items. So we tend to use these for comparing similar data for several individual items or events. So a bar graph can make clear how large or small differences in individual values are. So what we have is a graph on the next page, example of a bar graph. And this is the melting points of some common metals. So we could show the bar graph either going from left to right. Typically we're going to start it on either the y or x axis. So on this particular graph we're showing the metals along the y axis, and then we have the melting temperature along the x. We could very well have flipped that and had the metals going up the side, or up from the bottom to the top, and then had the melting temperature up the y-axis. But for this particular example, we're showing how the melting points of these 5 common metals compare to each other. So if we look at our table that we get the information from, it's a little bit harder to visualize. I mean, you could end up visualizing this information, especially if you had a lot more metals listed here. So it's easier to take this information and put it into, so take this information and put it into this bar graph form, so that it's easier to compare, how does the melting temperature of lead compare to iron? So we can see that iron melts at a higher temperature than lead does. Again, we have x and y axis here, but with independent and dependent variables aren't as set out with a bar graph, because there's not any experimental data that's taking place here. This is just comparing a couple of different items. The next thing we have are pie graphs. So with a pie graph we show parts of a whole. So with a pie graph we know that this particular example, composition of a winter jacket. So if we were to add this up, 66 plus 4 plus 30, this is going to equal 100%. So a pie graph is a good way to show this data when there's 100% of it. So add these up, you get 100%. So of this winter jacket, we've got 66% nylon, so this is 66% of the whole of what this jacket's made out of, or 30% polyester, or 4% spandex. So we've got those different parts of a whole. And that just kind of repeats that same information. A pie graph is ideal for displaying data that are parts of a whole. So if you know of 100% of a particular sample, then you could put it into a pie graph so that you could show how the composition is broken down. And we always show, most often, data in a pie graph as percent. So like we've got here, we've got 4%, 30%, 66%. So that's all I have on graphs for right now.